Hi, I'm Kevin Hauser, and this is the fourth video in a series that we're doing to support my new book. Hopefully you've seen the other three so far, and this kind of builds on top of that. Today, we're going to talk about troubleshooting first off, but then we're going to sort of hopefully wrap it up together at the end. Recently, I had a former student of mine who lives up in Canada, and him and his partner, they run a WISP up there in Ontario. And they had a broadcast storm. So they had a broadcast storm to the degree where their provider was affected. So I want to start by talking about traffic types for this video. So in this video, we're going to cover types of traffic and broadcasting in general, and how do we deal with broadcasting when it comes to Unify. Okay, because broadcasting does radically affect devices that are Unify devices, and we're going to go into some of the settings and show you actually how we can ameliorate, some of that problem in wireless. Okay, so that's what we're doing today. So first of all, let's talk about traffic and different kinds of traffic. A real quick slideshow, and then we're going to jump into the controller and show you how to make some changes. All right, so what we're going to look at is some traffic types, and hopefully this will help us understand some of the things that could lead to a broadcast storm or having broadcast problems. All right, so the first traffic type is Unicast. This traffic is basically traffic that people generate every day when they open up a web page. This is the most common type of traffic. It's also the least overhead on a network. So this is basically one device talking directly to one other device, and nobody else is really listening. All right, so that's what this traffic type is. Broadcast. Okay, now if you look at the description here, it's pretty involved. Sending a single packet on a network to every single possible recipient. Now, that could be a good thing. That could actually be a good thing if you're trying to find a service, right? So if you're looking for a printer, or you're looking for a web server, or you're looking for a Unify device running Discovery, or you're trying to get a DHCP address from a DHCP server, or you're using ARP, Address Resolution Protocol. So for instance, in ARP, you are asking the gateway, your default gateway, as reported to you from a DHCP server, you're asking that gateway, hey, what's your MAC address? I need to address a packet to you with your MAC address. So this is a type of a broadcast, right? So you may have seen in the controller where you can set the ARP timeout, or you can adjust that to a longer timeout so the client's not asking as much for that resolution. Broadcast, again, this is a very important type of traffic type, because you're getting this sent everywhere. Everybody hears this, and while this can be good, it can also be a problem as well. And we're going to see why that's a problem. The last type is multicast. All right, so multicast would be something like a streaming service, Apple TV. It's sent to some devices that are part of the multicast network, but not to everybody. So you can think of Unicast as one-to-one, broadcast as one to everybody, and multicast as one to some. So this is basically a more efficient form of broadcasting, because it doesn't consume all of these massive resources that broadcasting does, but it's a way for one device to talk to other devices. In Unify, multicasting would be something that you could also adjust or turn off. All right. So again, you'd have to decide, do I have devices that need to support multicast? Do I have Apple TVs? Do I have music on hold, MOH? Do I have that on my voice phones? Do I have a need to stream something? So that would require multicast. All right. Too many broadcasts in a LAN, in a wireless LAN, can cause drop packets, connectivity problems, slow speed. Why is this? Now, if you were to take one of my classes, we talk about this, and we actually will look some in-depth charts on this, because how broadcasting affects what's known as airtime. So airtime, by definition, is basically all of the stations receiving the same level of access to an access point. In other words, if there was 5 stations connected to one access point, everyone's getting 20% of the available airtime. Airtime is shared equally amongst all stations. The problem with that is airtime could get skewed by having a device send out a simple broadcast, right? So instead of that 20% of the airtime a device broadcasting can suck up over 80% of the airtime. So that can actually cause the first part, which is slower speed, connectivity problems, drop packets. This is why broadcasts can be detrimental to a unified network. Now, layer 2 devices like switches or radios will forward broadcast to every device in the network, even if they're separated by a bridge. What does that mean? That means on a large network, on a large flat network, even with radios, point-to-multipoint radios, somebody on one side of that network can broadcast, and it can go all the way to the other side across those radios. Radios, access points, and switches are all layer 2 devices. Now, once this broadcast hits a router or a VLAN, it stops. It doesn't go any further than that. But the idea is that a layer 2 device like a switch will forward this broadcast because it needs to. It needs to find that gateway address. It needs to find the DHCP server, right? So this is why broadcasts are important, but also why they can be detrimental. Now, the other problem with broadcast and multicast is the traffic. This type of traffic is actually low modulation rates. It's really slow traffic. It's designed to be robust, so it's kind of slow. So that type of traffic on your network will affect other stations on that network, right? So that is one of the issues. You see I label it yet another issue. So here we see what horrible thing could happen. So Mr. Klein over here, Mr. Smiley Faced, he's sending an ARP request off and it goes through a switch. Now, in somebody's infinite wisdom, they've wired all of these switches together redundantly. Okay, so what does a switch do? It's a layer 2 device. It forwards broadcasts out every single port. Generally, a switch will actually know who's on what port based on the MAC address, but it can never learn the MAC address of a broadcast. Therefore, it has to forward it. This is also called flooding. So flooding means that the switch 1 is going to flood to both switch 2 and switch 3. The problem ensues when switch 2 or switch 3 picks up this broadcast and forwards it again. So eventually that broadcast will get back to switch 1 and it'll just keep going. This is a typical broadcast storm. Plugging a router into a wrong port, plugging a phone into the wrong port, you may have done this yourself, can cause a broadcast storm to happen. So this can happen, right? So this is kind of what happened up in Canada. All right, so here we have, oh look, a Canadian flag. Radios are like switches. So this is how they originally wanted to set it up. They had like a base station, that's the one with the flag, and that one was the one connected to the internet, right? So that was connected to the internet, and then they had a couple other towers that they were connected to in a point-to-multipoint scenario. Well, because these radios are like switches, anybody on one of those other radio segments can send a broadcast, and it will go across all the way back to that home base, right? So because they hadn't separated this network out into VLANs and it was just one big flat network, this gives you a lot of overhead. Not a good idea to send a broadcast across a backhaul radio. It's probably not a good idea. All right, but that's what actually can happen here. Now, in the next slide, Canada. So their provider network, the little guy up at the top right, they had a private address, but they also gave them a public /24 that they were part of. So when they handed it off this to them with just your basic Ethernet cable and said, here, you're on this private network, they never routed that. They just stayed on that big flat network. Well, again, everything in the blue there is on one big network. Okay, so what does a broadcast do? It goes to everybody on the network. All right, so, and because the private IP, or because the private provider, probably a tier 2 provider, had redundant traffic, this created a broadcast storm. So this can happen. It was easily fixed, but again, this is the nature of a broadcast. It goes everywhere. This is why people with large networks tend to segment them into separate VLANs, which is basically a separate network, and a broadcast will not cross that network boundary. All right. So again, the problem was that the provider allowed a small network to broadcast onto its private network, causing a broadcast storm. types of traffic are important. All right, so according to Ubiquiti, we can mitigate broadcast using port isolation. All right, so that's what I want to show you, how to do that. All right, so let's jump back to the video. Like I mentioned before, broadcast can be a good thing, and it can also be a bad thing. So Ubiquiti recommends that you use port isolation when it comes time to having an access point, an AP, talk to a client. We're also going to look at port isolation in Edge as well. So we're going to see it in both platforms. We're going to see it in Unify, and we'll see it in Edge as well. That way you can see, you don't necessarily need to have an entire unified network to make this work. And again, what they recommend is setting port isolation. So if I have port number 4 on my Unify switch that is going down to an access point, and I don't want broadcast to go from a client on that access point back to any other client on that wireless, right? Then I'm going to isolate that port. And I don't want that broadcast to go any further than that port. So I'm going to show you how to do that. So that's what we'll do first. We'll look at it in Edge first, and then we'll look at it in Unify, how to isolate the port, okay? So hang on. Okay, so I have a simple Edge switch 150 here, and I've got it up in the new sort of pretty screen here, the new CLI. So it's actually really easy to do in this new screen to isolate a port. So you can see up here, you can see all the ports lit up here. I only have 2 ports actually running on this particular switch right now, number 1 and number 7. So it doesn't really matter what port I show you. It's all pretty straightforward. So let's just assume that we're going to plug something like an access point into port number 2. I can just go down to the little gear button, port number 2, and click that. And right here is the little checkbox isolate port. Now, this makes it super easy to do and super straightforward. It's actually really easy to do. You'll notice that STP is also turned on, and we're gonna talk about STP a little bit more at the end. But for this point in time, I don't want to get too far into it, but I want to make sure that you understand what that actually is, right? So I don't want to enable these 2 things, by the way. All right, there we go. So there we go. I have isolated port number 2 and spanning trees on. And I'm just going to go ahead and save that configuration. All right, so that's pretty straightforward in an Edge switch to do that. Really easy to do. Not a big deal, right? So let's look at Unify and see the difference there. So here's my controller, and I'm at the site setting right now. And I wanted to make sure that you're aware that under the site setting, there is a little box down here, a little section down here that says Auto Optimized Network. I don't have mine selected right now, but we're gonna look at that in a second, because I want to leave this off because I want to customize limiting my broadcast traffic. Okay, so the first thing we're going to do, let's go to the port on the Unify switch and we'll isolate that port. To do that, I'm just going to go to the devices, open up that screen. All right, to do it from the site menu, I'm just going to go over to devices, and I'm going to select my switch. And then on the right-hand side, my switch shows up. And the third icon over on the top is ports. I'll click that. And let's just say that port number 2, or let's say port number 3, I don't have anything plugged in there right now. Port number 3, I want to isolate that port. So I just go to the little edit pencil here. Pretty easy to do that, right? And go to Profile Overrides. Scroll down a bit. All right, and then I can select right down here, Enable Port Isolation. I can go ahead and just check that box just like that, okay? You notice that spanning tree on the Unify is also selected, but there's an informational button here. It says it's not recommended to disable this. In other words, don't turn this off. Loop prevention will be disabled. Okay, so again, if there was an access point hanging off of that port, I would isolate that port. That's what I would do. All right, and so we see how to do it in Edge. It's pretty easy to do. We see how to do it in Unify as well. Pretty easy to do. Now, I wanted to make sure you understand. Let me go back to the settings menu here. And I want to make sure that you understand what I meant earlier. So let's jump into wireless networks here, and I'm gonna go ahead and edit my wireless network here, and I'm gonna scroll down, and you can see down here we actually can see under advanced options, multicast and broadcast filtering, and checked right there, block LAN to wireless LAN multicast and broadcast data. All right, so what this does, this would allow a client on an AP to broadcast for a gateway. It would allow it to do an ARP broadcast. It would allow it to do a DHCP request, and it would go out to the wired LAN, to a wired server, probably running those services, and in turn it would come back as a unicast, because now the server has seen the MAC address of the source and it does not need to broadcast back. So when it comes back, it's a unicast. All right, so that's number one. But it's not going to, what this would prevent would be broadcasting back onto the wireless LAN, right? So the wireless driver actually is responsible for this and would stop that broadcast from happening. And you can see that you can actually have exceptions in here, like you notice in here the default gateway is the exception. So this is actually really important. Now I could do this on an entire site, on the entire site if I wanted to, by doing this under the site button, and doing it all in one go, right here under auto optimize. And if I turn this on, it'll actually tell you, hey, here's how we're going to optimize your network. We're going to increase your ARP timeout. We're not going to have broadcasting from the LAN, the wired LAN, onto your wireless network, right? So again, you can set this for the entire site, or you can do it based on each of your wireless networks. That's pretty straightforward. That's really not too complicated. But again, Ubiquiti recommends this for access switch devices, or devices that where the APs are plugged in, where the users are connecting to those APs. For switches that are interconnecting networks, you probably do not want to have this turned on, right? You're probably not going to isolate those ports because they actually will need to send certain types of traffic to other switches. Okay, let's stop there, and we're going to move on to the next part. Okay, we're back. So we just went over the real quick setting, both in UniFi and Edge, on how to use port isolation or how to turn it on. So again, if you go to the Ubiquiti website and look at some of their documentation, they actually will have a really good document on different traffic types and how to set up port isolation and how that actually works. Now the last part, and like I said, this is a pretty brief tour. I wanted to cover this one more time. What is broadcast blocking? So again, under wireless networks, this doesn't stop a station from sending a broadcast to the access point to forward it onto the wired network. It just blocks broadcast frames that are destined to the wireless interface, so the other way. So in other words, if there's another user on that wireless LAN, connected to the same access point, he does not receive a broadcast that some other user has sent out. All right, it doesn't go back to that other user. Again, so this will actually save some of that airtime that is really, really precious. And that's, again, in wireless, it's a concern. Having too much broadcast traffic is a concern. Now, the last part of this, which is quick and dirty, is spanning tree. Right, so it's a layer 2 protocol. It's designed to prevent and detect network loops. Right, that's its design. And there's actually several flavors of this. There's a rapid spanning tree, but basically at its core, right, it's designed to stop this circular problem that we have. Okay, so let's look at that switch 1, 2, and 3 again. With spanning tree turned on, the ports that interconnect these switches, spanning tree would instantly detect that, hey, there's a loop in this network. And what it will do, it will actually create what's called a root port and say, okay, from this switch to this switch, I'm going to use this port, and the other port I'm going to block. So in other words, it's going to block the port. Here it's blocking the port from switch 1 to switch 3, saying I can get there by going from switch 1 to switch 2 to switch 3. This would prevent a broadcast storm from happening in the network, right? That's the whole idea here. That's what spanning tree is doing. Now, here's the tricky thing. Not every switch has spanning tree configurable on each port. All right. Some switches some switches are configured for the entire switch, not per port. In other words, for the entire switch, it's either on or it's off. And that could be a problem. So luckily for us, in Ubiquiti, both Edge and Unify, we can configure it per port as we need it. Now, in another video, during this series, we're going to look at some complicated outdoor radio stuff where spanning tree can actually be problematic, right? And we may want to turn it off because of the problems it can cause us. So we'll actually see that as we move forward, okay? So, are broadcasts bad in wireless and multicast bad? They can be, yes. So we have to be prepared to mitigate that. Now, again, there's a lot of variables like how many people are on the LAN and how many users are on each AP. Do I want to have a redundant topology in my network? You can plan for all of these types of things, but again, you should be aware that broadcast in a wireless LAN can affect the network dramatically and cause problems with equal shared airtime. Again, airtime is precious. Here's the strange part about airtime. I mentioned those 5 clients talking to one access point. All 5 clients get equal airtime. Think of that as everyone gets their turn, right? To send data. Everyone gets a free, a free piece of that, a share of that. Now, this airtime is shared equally even amongst clients that don't have a really good signal. So that airtime will actually get skewed towards them. But in general, like I said, broadcast can definitely mess up the overhead for airtime. And you really won't see this unless you have a high density network or lots of users on an AP, but you'll actually see this, right? So this is something you should be aware of. That's the reason for this whole video. That's the reason for the book, to try to let you jump into the deeper end of the pool here and have a better and deeper understanding of what's actually going on behind the curtains, right? The beauty of Unify is that it's so easy to set up, right? It just is absolutely super easy to set up. The downfall of that could be that something you may not fully grasp or understand could affect, the way your network performs. So this is one of them. Like I said, there's lots and lots of wireless variables, and we should be aware of them and how to mitigate them and how to try to solve that issue. As far as the Canadian problem, it was actually really easy to do. Just put in a router. Once you have a layer 3 device, that broadcast isn't going to go any further than layer 3. So the public part of that IP that came from the provider, we put it on like a /29 network, and then we put everything on /28s, made separate subnets out of them. The router was happy, the Canadians were happy, the service provider was happy. Yay. Okay, so that's a good thing. I think it's important, like I said, to take these deeper dives, a little bit more in-depth understanding of even basic things like traffic. Again, if you think about a wired network, wired networks don't have a problem with broadcasting. You have all kind of safeguards to allow you to stretch that overhead. Not so much in wireless. So again, thanks for watching. More fun stuff next time out.